Good morning, everybody. Hello. In this video, what we are going to do, we are going to think about a new tool for proving. And we're going to do this by thinking about this question first that you see on your screen. Are these pen caps congruent? So let's check out these pen caps right here. For some reason, we really want to know if these pen caps are congruent. They look to be the same thing, but it's really hard to tell. So here's my question for you. How could we tell if these pen caps are congruent? What could we do? Think about that for a second. I have two ideas that we could use here. Idea number one is just if I had a ruler, could we measure? Could we measure both pen caps to see if they are the same size and the same shape? Because that's what congruent means. So, I mean, I guess I could try to measure, with a ruler and see, all right, they're both this wide, they both have a diameter of this much. But for some reason, that doesn't really sound what I want to do. I don't have a ruler near me, and even if I did, like the measuring of it would just be a little bit clunky and maybe not very exact. So another idea that I have is thinking about this question right here. Do I know if the pens are congruent? Because if I knew that the pens were congruent, then I think I would know that all the corresponding parts would also be congruent. So let's see. Well, like if you look at it, they look to have pretty much the same everything right here. They have the metal tip. They have the same green signs. They have the same barcode. They have the liquid gel ink. They have the same Energel sign right here. If you look at their two packages right here look to be exactly the same. They have the same numbers next to the barcodes. I'm going to say that that's enough, that these two pens are congruent. And if the two pens are congruent, then I think all of the corresponding parts are also congruent. So that's kind of an important thing right there to think about. So check out this green sign right here. If these pens are congruent, then its corresponding green sign on this pen, these two green signs are congruent because we know that the pens overall are congruent. So all corresponding parts of these pens are also going to be congruent. That's such a big idea that I think that we should write that down. So once we know that two, and I'm going to put figures here, pens, airplanes, triangles, anything. Once we know that two figures are congruent, then we also know that all corresponding parts are also congruent. This is a big idea in proof, and we're going to actually try out a proof right here so that we can kind of see, okay, how could I be using this in a proof context here? So take a look at this one right here. Write it down on your paper. Pause it if you need to take some more time here. So I'm given a four-sided shape with a diagonal right here, and I'm being asked, is side PM congruent to side UL? And here's my question. I do see two triangles. I want to kind of lay out an outline here of what I could do to see if these two sides are congruent. And my first question is, do I see two congruent triangles? And this is my question. Do I see PMU, triangle PMU, congruent to ULP? Because if those two triangles are congruent, I know that PM and UL are corresponding. They match up when they are put on top of each other. PM and UL are the same side in both triangles. So here's what I'm going to do, my outline right here. I'm going to try to prove, well, at the very end, I want to prove that PM is congruent to UL if that's possible. Now, so before that, I kind of need to prove that the two triangles are congruent. So triangle PMU is congruent to PMU, triangle LUP. And let's see if I can actually prove those two triangles are congruent. Let's take a look at what's given here. I know that, okay, LP and MU, they are congruent because of that dash right there. I also know that this side PU is congruent to itself in both triangles. So I have two sides. And here's a sign that means parallel. So I know that PL is parallel to UM whenever I see parallel lines, I like to kind of highlight them because I'm looking for transversal angles here that might be able to help me out. So I'm going to highlight PL, and I'm going to highlight UM. And then I want to kind of bold the transversal a little bit because that's how I'm going to be able to find if there are any angles that might be able to help me out in my quest to prove these two triangles are congruent. And now that I have my transversal, my parallel sides, I do see some alternate interior angles right here. I do see that this angle PUM is congruent to angle UPL because they're alternate interior angles. Okay, now I think I have side, angle, side right here. I know I'm going to be able to do this using side, angle, side. This is my outline. I'm going to prove these two triangles are congruent, and then I'm going to use our new thoughts about corresponding parts to prove that PM is congruent to UL. Let's do this. Let's start with our givens here, folks. I'm given, let's see. I'm going to start with my parallel bit. PL, side PL is parallel. Ooh, have we gone over this sign for parallel? If not, this is the sign for parallel. PL is parallel to UM. That right here is a given. We were given that. What else were we given? We were given LP is congruent to MU. LP is congruent to MU. That was also a given. Were we given anything else? No, I think that was it. Okay, so from my parallel lines, I saw my lovely alternate interior angle. So I'm going to make an arrow showing my flow of logic here to angle LPU. Angle LPU is congruent LPU to MUP. Angle MUP. And this is because alternate interior angles on parallel lines, on parallel sides, are congruent. Okay, let's see how we're looking here. We're looking just fine. Okay, so now we have an angle, we have a side, and we got to get that other side. It was also, we can use our reflexive property on this. PU is congruent to UP. Excellent. PU is congruent to PU is congruent to UP because of our reflexive property. It's congruent to itself. Okay, now I think we have enough for our side angle side triangle congruent statement. So let me write our triangle congruent statement right down here. Triangle PMU is congruent to triangle PMU LUP. And let's see it. I got to get some arrows in here. So here's my angle. Here is a side, and here is another side. And with the right order, it's side, angle, side. So the side, angle, side, triangle, congruence method. Okay, but if you think that we're done here, you forgot what our question was. Is side PM congruent to UL? Well, if these two triangles are congruent, then all corresponding parts of these two triangles are also congruent. So we can make our statement, our last statement right here be, yes, we do know that PM, side PM, is congruent to side UL. We do know that. And so what's the reasoning, you might ask? This is our new reasoning that we're going to be using here. Our new reasoning is that, just what we wrote up here, corresponding parts of congruent triangles are congruent. That's going to be our new reasoning here. So let's write that here. Corresponding parts of congruent triangles are congruent. Folks, that was your first corresponding parts of congruent triangles are congruent proof, and you'll be doing many more. Thank you very much for watching, everybody.